Thank you, Lillian.
Thank you.
Don't you think it's amazing that she knows this all by heart? I was really impressed with that. Thank you.
That's just my job.
Good. Yeah, Robert, you have to get there from all the way behind, so you have longer applause when you get on stage. Okay, so how do you reduce the cost of renewable energy? How do you solve, is it running? Yeah. How do you solve the fact that companies need to use less energy? How do you prevent society of using pesticides? These are the practical questions our customers face if it comes to sustainability, and which they are solving by using our technology called Cumulocity IoT. Welcome to my presentation about unlocking sustainability with IoT. My name is Bart Schouw. I am the Chief Evangelist of Software AG. So before I dive into those customer cases, we all know climate change is real. So for me, it's not a question about what to do, but are we doing enough? Can we do it faster? Can we scale? Are we still in time to at least stop it from accelerating? So some numbers for you. If we look on what's happening right now, so the first thing that I think is really good is that the regulators are stepping up. Lots of new regulations put in place, especially in the EU, on trying to prevent things from happening, stepping up our sustainability goals. And companies are responding to this. It is not only a burden, it gives us loads of opportunities for disruption. So one of the use cases I'm going to talk about is about a startup that is doing just such a thing. And then companies also start to realize, and I believe the previous presenter talked about it, it's getting close to us. So companies start to realize that this is something not happening to the neighbor, it can happen to you. So it becomes a real risk to the company. It becomes a risk to your future. So you have to do something about it. So many companies are stepping up. 90% right now feels the pressure to do something on this and are investing in this. And you can read about it in the annual report. Just go in and look at the Towards Zero programs that are gearing up. But the best thing, I think, for us over here is that what the World Economic Forum found out is that 85% of all IoT projects currently are addressing sustainable development goals. And that's a fantastic fact. But why? Why is IoT such a game changer in this? Well, if we look to the pyramid of sustainability, then it's very clear that reducing, minimization, and even prevention of using our precious resources is the name of the game. Reducing waste is the name of the game. And this is what you can do with IoT. You can monitor devices remotely and trying to prevent things from happening, optimizing the usage. And that's what we can do with this technology. So let me introduce some of our customers who are using our technology to do so. The first one is Nordex. Who knows Nordex? Raise hands. Yeah? Wind turbine manufacturer from Germany. Okay, already there for a few decades. They produce about, they have enough wind turbines installed to produce 40 gigawatt of energy. That's 10 nuclear power plants. And their name of the game in that industry is cost of energy. How can you reduce cost of energy? So if you look into the formula for reducing cost of energy, it's actually CAPEX plus OPEX divided by the energy production. Now, with IoT, you can't do much about the CAPEX side. But we do solve some of the OPEX issues. How does that work? You have to imagine that those turbines already have IoT solutions for decades. Homegrown, bespoke. In fact, they had, when we talked to them in 2018, they had about 6 or 7 generations of IoT platforms there. And they were end of life. They were hard to maintain and difficult to advance, hard to innovate. So we have replaced all those different platforms and provided them one single platform to connect all those turbines. So a turbine on average has 2,500 sensors, and we get right now 25,000 data points per second into our platform. That's about 1 billion messages a day that we need to analyze for them. But it helps them to reduce the maintenance cost, because with a small team, they can now operate a large fleet of devices. This is how that looks like. This is the digital twin, where they can see in real time how the turbine is operating. And they can also increase production. Why? Because I told you already, 1 billion messages, and many of them are alerts. So how do you go to so many alerts manually? You have to automate that. You have to provide them the right messages at the right time. And then get those turbines that are offline. By the way, every turbine that's not running is offline, okay? It's broken, otherwise it would run. So you just can count how efficient they are. So they have to get them as quickly as possible online again. That's the name of the game. And by automating those alerts, they can do that faster. And in this way, you just do the math, you decrease the OPEX, you increase the energy production, and they can reduce the cost of energy. Now, I know that what I've seen over here a lot, we talk a lot about the edge side in the story, and the whole edge continuum. And ideally, of course, you would like to do everything in the cloud and have your devices as thin as possible. So only send commands into your device and get data back. But in some cases, that's just not possible. There are too many sensors in there. Take your turbines, take your robots, take your factories that are remotely. So there is this trend back again that we are moving stuff out of the platform back to the edge. And in this way, reduce the data flow to the cloud, because data flow is bandwidth, data flow is energy. And so what we can do now is we take parts of the platform, distribute them as close as possible to the edge, and then command and deploy those configurations easily through Kubernetes, and then have those commands and raw data only at the edge where it's generated, do the analysis over there, and then send only the process data that is relevant to the cloud. So be aware of that from a future vision, that we'll see a revival of the edge again. And keep that in mind if you're doing your architectures. Now, talked about energy generation, now about energy consumption. Compressed air. Without it, every factory would come to a standstill. And that's not my words, that's the words of Oliver Prang from SMC. And they make pneumatic tooling for factories and manufacturers. And he told me that the average factory in Germany is using 7,000 megawatts. That's quite a lot. And 40% of that is used to compress air. That's amazing, isn't it? But now the real kicker, 20% of that air is lost due to leakages. Just like water, even worse. They can't see it. They might be able to hear it. And so what he's doing with our platform, he's monitoring the consumption. He helps their customers to understand where the leakages are occurring, and in this way reduce the energy cost. That's pretty cool. But there's an issue with factories. They are very much brownfield, very much closed shop. If you want to add a sensor to a factory, good luck. If you ask them to open the gateway, impossible, you know. So what's happening over here? How can we accelerate the adoption of IoT in such industries? Well, luckily enough, there are consortiums. There are consortiums about LoRaWAN, consortiums about low power M2M. But I want to point you to one that's called IO-Link. So IO-Link is for short-range, bidirectional, digital point-to-point communication. So it's an industry network standard and ideally suited for digital assets and actuators. And it really simplifies the implementation and also the cost, because often the wiring between the sensor and the gateway is the most expensive part, and that has they solve with very cheap wiring. And you also have partners like IoKey who can do the last mile into the cloud wireless. Okay, and this way circumvent that you have to go to the primary network of the factory. And this way, SMC installs their pneumatic tooling in brownfield environments easily and scaling. So IO-Link is now about 30 million devices out there that are adhering to the IO-Link standard. So it's getting there. Good. Third case. Here you see Benjamin Ruoff. He's from a startup Waynes, and he's disrupting the pest control business. And they have built an IoT-enabled trap. You see it over here in his hands. And the IoT-enabled trap even has a camera inside. I will talk about it later. So the pest control business is very traditional. It's very labor-intensive. There are inspectors running around checking literally millions of traps out there in logistical centers, in shops, everywhere. And because there are so many traps out there, they often only visit such a trap every 2 weeks, maybe every 4 weeks. So if they find something, it's often out of control, and they use a lot of pesticides to actually get it into control again. And also, you might ask questions about animal welfare. And the EU has dictated by 2030, we are not allowed to use any pesticides anymore. So how are we going to solve that? And this is the kind of challenge he is going after. So what they have done, they have created this IoT-enabled trap for rodents and for insects. And I want to focus on the one for insects, because insects normally walk on the glue, and then the inspector looks, hey, he has knowledge to classify, and he counts them and says, okay, this is infestation. I have to do something about it. Now, what they have done, they have put a camera on top of it. And with the camera, they actually make a picture, send it into our cloud, and then the pest controller can get an alert, and the customer can get an audit on this. And the way they do that, they use AI models to analyze actually the picture, classify the insect, and then count them and send that alert. Now, the issue of this is a LoRaWAN case, because those traps are often very remotely. And so the bandwidth is an issue, and the battery life is an issue too. Now, I already noticed also from Christoph talking about how AI is moving to the edge. Here we have a case where they're using AI at extreme edge, because, and I want to point you out to that, that there is a company, Sony, who has built now a AI inference model on the chipset. So once it makes a picture, it can automatically analyze the AI model and give you an answer from the classification side. So low power, less bandwidth, and solving all kinds of privacy issues. And we're working closely with them to get this to market. So if you have questions about that, for your opportunities, come to me. Good. All those 3 cases are actually powered by Cumulocity IoT. And this way we solve the sustainability challenges of our time. And the way we do it is we deliver you device connectivity, device management, analytics, integration, and visualization. But in a buy and build manner. What do we mean with that? Once you start your solutions, you often want to do it quickly, have quick results, because you don't have big budgets. You need something to show to your management so that you can continue to invest. So we go after a 6-week kind of implementation life cycle with a zero-code approach. So not too many developers involved. And once you have shown your value and you want to extend, then you're free to add your development capacity and really build your differentiators, really build your solutions, and show the customer your opportunities. That's the advantage of working with us. Well, if you want to know more, my time is up over here on stage, but I'm still there at the booth. Thank you for your time. Enjoy the day.